Hi, in this video I will show you how we can integrate the class library package provided by DIS in an automation script. It contains validated code and easy to use, and even more important, it's maintained by us and the bigger community. So this means if something happens in the underlying hood of DataMiner, we just apply a new class library package and we don't need to change your automation script. There are numerous reasons why you should use a class library package. It's validated code and robust and according to our standards. Moreover, if you're using it in an automation script, there are also multiple methods that are not off the shelf possible in an automation script. Now also you can use it for communication between the automation script and a protocol, which we are going to do in this video today. Let me first show you in the DataMiner help where you can find some more information, how a package is created, what it contains, and how it is maintained. Under the advanced DataMiner functionality for administrators, you can find the DataMiner Integration Studio, and then you go to the reference of it, and there you can find the class library package. Here you can see some descriptive information about it, how it is contained, what is contained in the package, and also how the version is going. Now, if you need some more technical information, I refer you to the DataMiner development guide, which is exposed on the Dojo platform. So let me show you that. You go to resources, and in the bottom, you can find the DataMiner development library. Click on it. And as you can see, next to the protocol and the automation reference, there's another section called the DataMiner class library. Here you can find all the references and all the methods that are exposed by the class library package. As I already told you, DIS ships with the class library package. So go to the DIS menu, go to settings to see which settings we can tweak on the class library feature. Of course, we have to enable the class library feature, and I suggest you also to automatically generate the class library code. This will be used whenever we use the snippets also shipped with DIS to automatically generate the class library and also add the necessary references. In today's video, I will show you a feature that requires a higher DataMiner version than the one provided in this class library package. So I will select this package. Now, in my use case, I have a simple script with one C# block with empty methods and no references. Now, there are two ways to introduce the class library feature. First of all, you can go to DIS menu and also go to automation scripts and click on generate class library code. Now, there's also another way by using the snippets, as I already told you. So click on this icon to open the automation script C# code. And here I can show you how we can introduce the class library feature. We insert the snippet by clicking on Ctrl+K(X) or by right-clicking and using the context menu to insert the snippet. Now go to DIS, of course in an automation script, it's a class library feature, and in today's video I will show you how we can communicate between an automation script and an element, so we use the enter-app feature for this. The getDMS is often used to get a DMS instance where you can get the views, get elements, and do all necessary actions on those returned objects. So we go to enter-app and we want to send data to an element and get the data back again. So we use the send enter-app app with response. We click on enter and we see that all code is automatically generated. Now it contains two compilation issues. First of all, we need a message and we also need an element. But let me first show you what happened in the background. We see that the code is generated, and also see that automatically the references are added. Now, this is not the only change. As you can see, there's a new code block added, an exe block with the ID 63000. And here you can see that automatically all the code that is necessary in your automation script is added over here. Also, in the end of the script, you can see that the reference is added to the DIS library. This is used so the exe block with ID 1 knows or has the reference to the class library. Now, how we can solve these two compilation errors is by, of course, introducing the element which we retrieve from the engine object by using the dummy that we provided in our script. It's called singular life. Now you can see that the message, we don't have a message. So what do we need? We need to use another snippet to introduce a message. So we go to DIS, automation script, class library, interrupt, and here you can see that there's another snippet called my message. It introduces a class that will be used to send the data and serialize that specific class. So this class should be exposed both in the sending end and the receiving end. For this demo, I will just introduce one property and I will use this message to send the data. So we create also the message, this new my message, and we assign a property to the contents, and then everything is fine. Now, what happened with the automatically created code? It says to create a command so we can send the data, and over here it sends the data to the element that we want, element singular life element, and also it sets the data on this parameter. It has a time span of 10 seconds. Now also the receiving end has to know some things. It might want to know from where it's coming from the automation script. So here we can provide it in the source. It also needs to know if it's required to send a response, where it should set that response. And by this, we use a return address. We say on the same element that we're sending the data, we want to set the element, the parameter ID, this parameter ID, and it will use that parameter set to get the data. So you might have noticed a lot is going on in the background, but we don't have to know everything. We just want to send data and get data back. Now, what happens in the background is not important for us, because there are subscriptions, there are SLNet calls, there is serialization that we all don't need to know. In another video, we showed you how we can use an automation script to send commands to singular life to stream a movie. Now, by looking at the code, I have seen some things that are not really optimal. It's not because of the quality of the code, it's more because of the methods exposed by the automation engine. Now, by using the class library feature, we are adding possibilities to make it more optimal and efficient. We are going to use the interrupt feature, which is used to communicate between an automation script and an element. Now, let me show you a use case. The current flow goes like this. From the automation script, we send the request, the element receives it, and executes the new flow. Now, in the meantime, the automation script is going further to the receive step and now pulls each second a table on the element to see if the flow was already added. Now, instead of polling based, we can use the interrupt feature to make it event based. So let me show you this. It still sends a request to the element receives it and also executes it, which is actually the same as before. What is different now is whenever it finished the try execute method, it goes to the send phase where it sends the data and sends a new flow ID to the automation script. Whenever the automation script receives the data, it continues. Now, let me show you that in the automation script. This is the existing automation script. We just sent the request to the element, and then for a number of 30 retries, we try to get the active flow ID. As you can see in this method, it gets all the primary keys and checks if that specific parameter from that row has the same app ID. And then it waits for 1 second. Now, we can use the interrupt feature to make this a little bit more optimal. So, like before, we initialize the interrupt. This is more the information that the receiving end requires, like the source, the request that we sent, and the return address. Now, we just send the command to the element on this parameter, and we wait for a maximum of 10 seconds. Whenever we get a response, we check if it's a new flow response, and we return the message. From then on, we know that it's a valid object that contains the ID that we need. Now, in order for the singular live element to know how the data is sent and that it has to send it back to the automation script, we also have to tweak the protocol. I have introduced 2 new parameters, one for the receiving data and one for sending the data, and also introduced a new quick action. Here we can see that we just deserialize the requests, we execute, and we send back the data. Now, for using the execute, you have seen that there are a couple of methods used to parse and make the execution of the data. Now, for this, a flow executor is used. This is introduced by just using another snippet provided by DIS. Here it goes over all the methods that were described in the diagram, where some of the things is getting data, for example, the authentication token, setting the data if a response is already received, and of course, getting the response from the Singular Live API. Now, let me show you this in action, how we use the executor and all the interrupt features to send back the data to the automation script. As you can see on DataMiner, I have a singular live element where I don't have any flows, and also I have one stream available to make a new stream. So let me show you this. I open the new stream script where I use the singular live element and the main stream. I click on execute now, and automatically I see that a new flow is added, and also in the automation script, I'm waiting until this status is set to running. Whenever this is set to running, I see that the VLC stream 2 is also set to running. So I know I received some data back from the element, and I was able to continue and send my commands to the VLC stream. In this video, I showed you how we can use one of the many features of the class library package to make an automation script more optimal.